Dynamic Host Configuration Protocol. What is DHCP? Why we require DHCP Dynamic Host Configuration Protocol? What is the DORA process? DHCP LEASE, DHCP scope. We are going to discuss all this in this discussion. The first question whenever we talk about anything is why it is required. Similarly, why DHCP is required. Your house, your home, or even your network, your office might be having mobiles and tablets, and there are so many devices, computer, servers, etc. Now, if you want to keep it in a private network or a public network also, every device ought to have an IP address and network configuration. Without IP address or network configuration, nothing is going to work, means the communication will not happen. So IP can be given normally, IPv feed or private network addresses are there. But the DHCP is all about automatically assigning the IP. You don't have to manually enter always. If your computers and the systems connected to the network are huge, feeding in the IP will be very difficult. So as I was talking about a private network, these are the ranges you have to enter. And this will be huge task if the number of computers connected or system connected are too much. So your router in your house does exactly this. Using the DHCP, it assigns all the gadgets attached. It assigns automatically IP and convert it to a short network. All right. So if you have a huge network, it's always a good idea to have automatic IP assignment and network configuration. So this is a network. We have certain IPs being given. Okay. Imagine you have given it manually. A computer is now added to this network. So this IP you can feed manually. For example, you have IP of this range. So you can give 192.168.1.5 to this IP. But it will always happen. The computer will go and come in your network. Means the network cannot be always static. It is not fixed. The IP has to be given, it has to be taken. So there is no point, there is no idea, there is no background to actually reclaim that IP which you have already assigned to that system which is already gone. So in DHCP, we have a DHCP server. It controls or it have a pool of IP addresses, and these IP addresses are leased. They are just given for a certain period of time. It is not always assigned. It is not permanently assigned. It is given on lease, and if a computer breaks or it goes out of the network, this IP is reclaimed. It is reclaimed back to the IP pool of the DHCP server so that it can be assigned to any other computer who is going to join the network. Okay. What is DHCP? What is Dynamic Host Configuration Protocol in networking? Why is it required? And what is exactly it? First thing comes here is dynamic. That is dynamically assign. Computer join, computer go. Dynamically assigning IP, dynamically taking out reclaiming back the IP. Okay, host are the computer being joined. And protocol is all about RFCs, that this is the framework which is being developed and that everyone has to follow. And configuration means giving certain parameters to make it aligned to work with us, to work for the computer, to work for the network. Okay. So what is happening here is DHCP or Dynamic Host Configuration Protocol, the system also and the server also, it dynamically assigns an IP address, but not only IP address, all the other network configuration parameters. Only IP is a basic, but only IP cannot be, said that, okay, it will be enough for the communication to happen. No. Other network configuration parameters like the subnet mask, like the default gateway and the DNS server to each of the client, or you can say device, because this is a client server model on a network, so that they can communicate with one another in IP network. So this one is the IP address, this is your subnet mask, and here you have the default gateway. Okay, you can also add the DNS, domain name system. This is also here. So the whole idea is there is a pool of IP addresses which can be assigned to different computers joining the network, and this all happens dynamically, no manual entry. So DHCP, the DHCP server is there. As I said, server client model is there. The clients are all your host, and DHCP server is what is giving the DHCP or using the DHCP. So DHCP server assign each client with a unique dynamic IP address. Why we are calling it as a dynamic? Because lease, because in Windows the time is 8 days to lease, to only give for a certain period of time. It can be 12 hours also. After 12 hours, this IP which is being assigned to any host will be reclaimed back, will be taken back. Okay? Because this IP is only given on lease, not permanently. What will happen as a network administrator? That whenever a system join or computer join a network, you have to feed it manually, without DHCP. It can be 3 computers, it can be 3,000, it can be 3 million. In big networks, you cannot enter IP. It is unmanageable, unsustainable. That is why DHCP is all about dynamically assign the IP to all the computer networks. So DHCP by itself, it has not come. This bootstrap protocol, this was a network IP management protocol in 1985. So DHCP is actually based on this bootstrap protocol, and DHCP is an IEEE standard. So it is very important. This is you can say standardized. So we know what parameters it use, how the protocol works. So it all started with bootstrap protocol. So you might be asking why bootstrap is not working now? Because there are so many manual entries we require. Boot P will give you dynamic IP, but it wants the MAC ID to be entered manually. Second thing, it does not provide any kind of mechanism or the process to reclaim the IP addresses when the IP addresses are no longer in use or the system has stopped working in the network. So there is no way of reclaiming the IP address. That is why this DHCP came. So this DHCP, if you see RFC is all about request for comment, and this is standardized, and this is you can say organizational. So 2131 and 2132, and who is going to implement? Internet Engineering Task Force, IETF, and this on 2131 and 2132, this is based on bootstrap protocol. Now on which TCP IP or ISO OSI layer stack we have? So DHCP is an application layer protocol. So it works on here you see, it works on the application layer of the TCP IP protocol stack. Okay, this is also standardized, you know about that. So DHCP is very important in networking. Now you have a server and a client. Now imagine that these DHCP messages from client to server. So we are talking about DHCP server now. So DHCP server will use the port 67. Which one? 67. This is not on the client. Please remember, I'll just cancel it. It is DHCP server. This is very confusing, right? So remember, DHCP server always use 67 port because DHCP messages from client to server are sent on this port. And DHCP messages from server to a client, these are sent to the DHCP client port, and this is 68. This is always asked. DHCP server port 67, DHCP client port 68. Alright. Now let me give you a very brief idea how exactly this DHCP works. There is a handshake process. Whenever a computer joins a network, it will ask for IP. So it doesn't know where the server is, it doesn't know its own IP. So it will broadcast a DHCP discover packet. It will go broadcast this to everyone. Now the server will get this DHCP discover and it will say, okay, this is the IP, this is the network configuration I want you to, I offer you. This server sends it to the client. Now client gets it and it says, oh, thank you for the offer. Please give me this configuration which you have just offered. I am ready to take it. And finally server says, okay, now I'm adding all these content like the network configuration I am going to provide you on the database, and this is the acknowledgement. So this is kind of a receipt. Now they both are happy. One has given the IP, the other has taken the IP, one has added the IP on the database. And that is final end of the handshake process, and this is how DHCP works. In DHCP, or the execution of Dynamic Host Configuration Protocol, the process is DORA. Okay, this DORA is just the alphabets of the 4 steps being taken. So we have a 67 port DHCP server. The client port is 68. You know about that. DHCP server port 67, DHCP client port 68. So whenever a new computer joins in a network, what this computer will do? It is naive. It doesn't know anything. So the first thing it will do in this DORA process, D is red here. So we are going to talk D here. So in DORA process, this D is all about discovery. It is a child in your network. So the first time this DHCP client computer, it tries to be in the network or log on to the network, it requests an IP address information, and not only the IP address information, the network configuration information from a DHCP server by broadcasting. Please remember, the messages are broadcasted as a DHCP discover packet. So the client will send a DHCP discover packet. It says, I am new in network and I don't know my IP. I don't know anybody's IP. So I have to broadcast, because if I would have known the IP, I would have unicasted. So that is why it is broadcast message where the source IP address is 0000, because the client doesn't know yet. It has no IP address. Destination also it doesn't know, so it will broadcast, and broadcast address is always ff.ff.ff.ff. That is 255, 255, 255, 255. So this is the DHCP discover packet, and this packet will go to any of the computer, any of the server which is attached on the network. Now DHCP server knows that, and it is waiting for, it is listening on that 67 port. So it will get the DHCP discover packet. Now second step comes in here. This is called the DHCP offer process. So DHCP server receives that DHCP offer packet, and each DHCP server, because there can be more than one DHCP server that receives this client DHCP discover packet, which was sent when the computer joins into the network. So this DHCP discover packet respond with a DHCP offer. That is why we call O here. This DHCP offer packet containing an unleased IP address and the additional network configuration. These are the IP address, subnet mask, and the default gateway. Okay. So now for the DHCP request, DHCP offer is being made by the server. So it says, I am sending you an offer now. This is the IP I am going to provide you. This is the default gateway, and this one is the subnet mask. Second one is the subnet mask. Third one is the default gateway. Now this is DHCP offer made by the server to the client. And everything is broadcasted, please remember. Okay. And now this goes, there may be chances of failover. So as I said, there can be multiple servers. So more than one DHCP server can respond with a DHCP offer packet, because there cannot be only one server. There can be multiple servers. So everything is happening in all of the network. The client will accept the first DHCP offer packet it receives from the different servers. This is the step of O, offer. Two steps are being taken. One is request, one is offer. The third one, or the third process in the DORA process, is R. This is DHCP request. Now client got an offer from the server. So when a DHCP client receives a DHCP offer packet, it is going to respond by sending DHCP request packet that contains the offered IP address and the network configuration, and it shows acceptance of the offered IP address. The new system will say, I like your offer. I generally want you to lease me these network configuration parameters. Please give me that address. Okay. This is on lease. Please remember, the network configuration and IP are provided only as a lease for certain period of time. This leasing from DHCP server is not permanent. So this is called DHCP request, that I like your offer. The client says, I like your offer. Please, I'm begging, please give me these network configuration. Okay. Now the final step or final process in this DORA process is A. What does it mean? It is acknowledgement. So DHCP acknowledgement, the DHCP pack or DHCP ACK. So now DHCP server says, okay, if you agree with what I am going to offer you, once this DHCP server receives this DHCP request, it will store all the network configuration parameters on the DHCP database. And then it will again broadcast this DHCP ACK. ACK means acknowledgement message. So I have updated the record in my database. That's what DHCP server says. And it says, okay, now I am authorizing you. So the DHCP packet is an acknowledgement by the DHCP server to authorize the DHCP client to start using the network configuration parameter it received from the DHCP server earlier in this step 2 process of this process. Okay. Offer. In offer, what was being given? Now finally it is being acknowledged. So we started with D, discover, and finally the acknowledgement take place. This is how this whole system works. DHCP scope. What is DHCP scope? In one line, it is the start and end of the IP addresses which a DHCP server has that it can lease to the clients. DHCP is all about offering the network configuration parameters to the new computer joining and the existing computer in the system. So scope is the range of IP addresses, the amount of IP addresses, the pool of IP addresses that DHCP can offer to different clients. So DHCP scope is the range from here, if you see here 1 to 100. So this is the range of IP addresses that are available to the DHCP server that it can lease out, because the IP and network configuration is leased out, not permanently given. So to lease out to DHCP enabled clients on a given subnet. So why we are, IP addresses are always there. Why we are learning scope? See, this scope allows a DHCP server to make different subnets. What it will do? From 1 to say 50, it will give to one subnet, and 51 to 100 it will give to another subnet. So scope is typically defining a single physical subnet. You see in this diagram 2 subnet. So it is defining a single physical subnet on your network to which DHCP services are being offered. So the primary function is to decide which IP addresses the server gets to offer the client, can give the client. So how does this work? This is the actual picture of your Windows. Start IP address and end IP address. So this is the start and end. You can divide it. You can divide the scope in different ranges. So here you have the subnet mask also being given, and there is a proper range that can be defined, and that can be assigned to certain computers, or it can be assigned to make a subnet, that is small network in a network, right? So this is how subnet mask is used, and whenever subnet mask is used, that means a subnet or a smaller network is being made. So user can create many scopes as required on a DHCP server. You can have 10 of this scope, or you can divide this range in 10 parts, 20 parts. It's up to you. Before building the first pool of available IP addresses, very important to plan it, because you can have a server, you can have a router, you can have a printer. You will not give the dynamic allocation every time. You have to give a static IP address and network configuration to these devices, like the servers, router, even printers. They are always static. But other computers which are coming and going, they can be dynamic. So whenever you want to assign to those systems which everyone use and you don't want the IP address to change, then the static IP addressing can be employed here. So many administrators place all statically assigned IP addresses at the front of the scope. Now let me give you an example how you can do that. DHCP scope is how does we perform this scoping to make the subnet or to assign static and dynamic IP. So this is an example, and you can have a scope address range. For example, here 192.168.2.0/24. This is 24 bits. The first 24 bits are the network address. Okay. Now the static IP addresses in this example, we can give like from 2.1 to 2.25. That is, you have used from 2.1 to 2.25. You can give the static IP addresses to routers, servers, printers, and other devices which you don't want this IP address to be changed. But be very sure, because you need to have some additional devices. There can be more printers that can be added. So that is how you have to make plan when you are actually doing the DHCP scope. The second thing is the dynamic IP addresses. So as I said, we have different computers or clients which are going to join and which are going to leave. So these are the dynamic IP addresses and the network configuration which can be provided, which can be given to different clients. DHCP, Dynamic Host Configuration Protocol. What is lease? Now if you want to take a house, say as on a rent, you will have a kind of contract of lease between you and your house owner. So for example, 11 months of lease you take. So if you are good, then you can continue it. Otherwise, you have to leave the house. So there is always an agreement in every relationship. Here also we have a client and server relationship. We have a DHCP server and we have a DHCP client. So what happens whenever a new client comes into the network, there is a kind of contract is made from DHCP server to the client. So this IP is being assigned, network configuration is assigned, but it only these IPs which I am assigning right now, or you are watching being assigned, it only is assigned on a lease for a specified period of time. So DHCP server assign IP address and a network configuration to a client in the form of lease, only a temporary time arrangement or assignment. Okay. If you go to Windows, the 8 days is the default time. In Linux, you can change it. It can be minutes, it can be seconds, it can be hours, it can be days. So when using the DHCP in order to manage the pool of IP addresses, each client which is served on the network is only renting the IP address on lease, not permanently taking it, or the assignment is not permanent. So this is how it works. This is the actual picture of your system. So this is your DHCP setting and here is your lease time. So this is a lease for a specified period of time which is eventually going to expire. Okay. So the IP addresses managed by DHCP server are only given or only assigned on a lease for a limited period of the contract time. Normally the standard DHCP lease time is 24 hours. Normally. But in Windows it is different. As I said, 8 days. In different operating system, the time can be changed depending upon the settings. So unless this default settings are modified, DHCP server are going to assume that your IP address is just temporary and it is going to expire after that lease time or the specified period of time. And this is very important, very beneficial, because, for example, this system is not in the network. What will happen to the IP address? If you have permanently assigned it without a lease, if a new system is coming, so this IP address can be reassigned to a new computer which has just joined the system. Okay. So giving the IP and reclaiming it is very important. So whenever we make an agreement, say you are a tenant and you have a house owner, so 11 months is the time you make a contract on a stamp paper. But after 11 months, what will happen? Either you will stay in the home, or your house owner will say, oh, somebody is coming, so you thank you for your visit, you stayed here for 11 months, thank you, and now you can look for some other house. So whenever the IP address and the configuration parameters is given by the DHCP, it is always on the lease. So the client can renew this temporary assignment, or you can say the client has to apply for the renewal. So DHCP has two timers, T1 and T2. Now this can be set always, there are settings, but the default values is, if you are using T1, it is 50% of the lease time. T2 is 87.5% of the lease time. Now what does that mean? The T1 is called a renew state. It is a renew state. So when you are assigned an IP address and the network configuration, say for certain days, I will take an example, don't worry. So this renew state, it is a first timer which starts at the 50% completion of lease period. Now this is your client, this is your server. Now server has already assigned an IP to the client. Now client is enjoying the IP and working fine. Now the IP is assigned for say 10 days. Until 5 days, the client will do nothing. It will enjoy the network communication. After 5 days, that is when once the 50% of the lease time has expired, it will start the renew process from the same DHCP server who has assigned the IP to it. So the client computer submits a request to renew the lease to the DHCP server after expiry or completion of 50% of the lease time. For example, we are taking 10 days here. Okay. Now everything was going in the broadcast when the DORA process was taking. But now here everyone knows, both the parties know the IP address. So this lease renew request will be unicast. Alright. Okay. Now if the DHCP server is online, it will accept the request and it will renew the lease, and the timer will again start from 0. Okay. If the DHCP server is on, it will accept the renew request and it will give, okay, you can again start from 0. So from 0, the time will start, and again the same process will be there. Again it will get the 10 days, and for 5 days it will be very happy to do nothing. Means in terms of renewal process. This is called renew state. This is again the lease renewal accepted is also unicasted because both know about each other. Now T2 is the rebind state. What does it mean? First timer was 50%. So the 10 days are there. After 5 days, the renew request will be initiated by the client. What will happen if the server is offline or server is not there? What will happen? Okay. All the network configuration it has got from some server, this client, but the server is not there. The server is offline, say. So it will keep trying after 5 days and keep trying ever. That is why this T2 has come. It is a second timer which starts at 87.5% of the completion of the lease period. You can take 8 days, for example. Okay. So till 50% completion up to 87.5% completion, this system is going to try again and again for the original server. But once this 87.5 lease time has expired, now it will try with everyone. It has to broadcast DHCP discover broadcast process. It will broadcast it as in DORA process. So it will ask every server, oh, my time is expiring. Please give me IP. Please give me IP. My original IP server is I'm not able to contact. Okay. So what will happen in case the client computer could not renew the lease due to DHCP server unavailable by this time, so 87.5%, this will happen. Okay. So whichever, say other server is up or it is online, it will give the IP address now. Okay. So this is the binding state. Here it tries to locate a new server and tries to acquire different IP address. So the problem is here, the IP address will be changed as a new server will give a new scope, a new lease. Alright. Because everything is about IP and network configuration. If it changes, if you are doing some work, it will change for everyone. But in IPv6, in the bind state, if a new server is assigning the IP and other configuration, this will not change. This IP and configuration will not change. This is the beauty of IPv6 now. Okay. Now what will happen when DHCP server is offline during the client startup? So client, we have already seen after, because this IP and network configuration is leased, not given every time. So if server is available 50% of time, which is assigned, the client will try. It will try again after 87.5% time if it doesn't get the request, the response from the server if it is offline. After 87.5% of time, it will ask everyone, oh, I am not getting the IP, please give me the IP. So if the client computer is still under the lease period and there is no DHCP server available at startup time, then the client computer will ping to whom? It will ping to gateway. Okay. There is no DHCP server. What the client should do? It will contact the gateway that was assigned previously by the DHCP server. Okay. Now the thing is, there is no DHCP server. All are offline. It has already tried after 87.5% of time. Okay. So this server has already given the IP and subnet mask and gateway. So it will contact the gateway now. If gateway respond back, then the client assumes that it is still in the same network. So it will start using or it will keep on using the same IP address. But if the client can't get response from the gateway also, it will consider itself out of the network that, oh, I'm not getting response from gateway, so I'm out of the network. So there will be an auto configuration IP address process, and which is called as APIPA, APIPA. Okay, this stands for automatic private IP addressing. These are the features of the later Windows operating systems after NT, etc. So with this APIPA or automatic private IP addressing, DHCP clients can automatically self-configure an IP address and also the network configuration like the subnet mask when a DHCP server is not available. So the APIPA IP range goes from 169.254.0.0 to 169.254.255.255. So when nothing is available, there is a possibility of APIPA if you are using the Windows system. Okay. There are other ways also. When the client start up and it is not getting an IP address, there are other ways also. This is just a way you should have an idea that this also does something. So I hope you have a better idea of DHCP now. Thank you so much. Take care of yourself.